Hi there, let's have some fun with quadratics. Math is always more fun when we have some great word problems and we can use our skills to solve them. So let's get into some quadratic word problems. Okay, for most of these problems, we will use the null factor law. Let me just remind you what this law is. It is the idea that when we have two factors, two things being multiplied, and they equal 0, then one or both of the factors must be 0, because the only way we can have a result of 0 from multiplying is if one of the multipliers is 0 itself. For example, this is a factored quadratic. We have something here times something, and it equals 0. Therefore, this factor, 3x, must be 0, or this factor, x minus 5, must be 0. This is the standard way of solving quadratics, because now each equation can be solved for x, and we have two solutions. Over here, same thing. One factor, another factor being multiplied equal to 0. Therefore, the first factor is 0, or the second factor is 0. Solving each little equation, we get two solutions for x. Okay, that's the null factor law. We will use it for every word problem we solve in this video. Let's get started. Here's our first problem. This function right here, which is a quadratic function, represents the height of a kicked football, with t being the time in seconds after the kick. So these variables here represent time, and it doesn't say here, but h represents the height. Okay, find the times at which the ball was at a height of 14 meters above the ground. So imagine a ball flying through the air. It will go up and then down. On its way up, it will be at a height of 14 meters. And then again on its way down, it will be at a height of 14 meters at some point as well. Imagine that arc, and it reaches that certain height twice. Your goal is to find out when. Well, we know the height we're looking is 14. So why don't we replace this h with 14, because we're saying height is going to be 14, and then we can solve for t. Let's try that. Here's our function, replacing h with 14, because we're saying we want the height to be 14, and we're going to solve when that happens. When we solve for t, t represents the time, so we will know when this happens. How about you give it a try? Okay, when we solve quadratics, again, our goal is always to get 0 on this side. So that 14 is being moved to the other side by subtracting 14. And if we have negative 1 minus 14, we end up with negative 15. Now we have a quadratic trinomial. Let's see if you can factor this, because if you can factor this, you can use the null factor law to find two answers for t. Okay, this, I have simplified it. Often life is easier when the coefficient in front of the squared variable here is is not negative, it's positive. So I multiplied everything by negative 1. So this turned positive, this turned negative, and this turned positive. Now let's factor that. Okay, this one I didn't show the little x, so I didn't show the x factor, but we are multiplying 2 by 15 to get 30, and we're thinking of two numbers that multiply to 30 but add up to negative 13, and those two numbers are negative 3 and 10. Okay, now that you have this, you can factor by grouping. So continuing on, check your work, and complete factored form is this. Now we have something times something equal to 0, therefore each separate factor can be set equal to 0 and solved. 2t minus 3 equals 0, and t minus 5 equals 0. This one here solves to 1.5, because we move the 3 over and divide by 2. And this one solves to 5. That tells us that this ball will be at a height of 14, because that's what we began by solving here, putting 14 for h. This ball will be at a height of 14, 1.5 seconds after the kick, and 5 seconds after the kick. Let's look at what the graph looks like, because it will show us more clearly what this is representing. Okay, so here I entered the function that we're given, this quadratic function, and I graphed it in Desmos, and I can see this graph. It's a parabola. All quadratics, when they're graphed, look like parabolas, this shape. So we can see, and again, the y-axis here, this is like our y, represents the height of the ball. We have h there. And the x-axis is time, in seconds, time after the kick. So as the seconds go by, see, after about 6.5 seconds, or 6.5 seconds or so, the ball will come back down to the ground. Okay, so where is this 14 we're talking about? Because when we set the equation like this, right, we took our function, we set it equal to 14, we're saying, when is the height 14? So look at the here. Here is a horizontal line, h equals 14, or you can think of it as y equals 14. A horizontal line always has that kind of equation, y equals some number. So h equals 14, this represents a height of 14, and you can see the ball is going here, and at this moment in time, it is at a height of 14, then it goes higher, lower, and at this moment in time is at 14 again. And we just solved those 2 points. We found the solutions. When we solved this equation, we got an answer of 1.5 and 5, right? Here's our 2 t values, 1.5 and 5. And we can see those 2 coordinates. This one's at 1.5 seconds, the ball's at 14 meters at 1.5 seconds. And over here at 5 seconds, the ball is at 14 meters as well. Okay, so yeah, sorry. Okay, now my next question for you is then, what do these 2 points represent then? Explain those in your own words. Okay, I hope you said those are the points where the ball is on the ground, because at that point, the height is 0, right? If we draw a horizontal line here, the height is 0. Those are the 2 times the ball's on the ground. So when it's first kicked, goes up, and then when it lands again. Okay, and those 2 points, just so we know, are these coordinates here. So at 0.078 seconds after the clock was started, the ball was kicked, and then at 6.42 seconds, it landed again. All right, so another question. What about this point? What does that represent? And I've given you the coordinates of it. This is called the vertex of our parabola, but in our situation, what does this vertex represent? Okay, so it tells us that at 3.25 seconds, that's our t value here, or x value, the ball is at a height of 20.125 meters. So that's the maximum height the ball reaches and the time at which it reached that maximum height. So now I'll ask one last question. We can draw in a parabola a vertical line that passes through the vertex, and it actually splits the parabola perfectly in half, symmetrically. So this is called the axis of symmetry for a parabola. What is the equation of this axis of symmetry in this parabola here? Well, that equation is t equals 3.25. Any vertical line has an equation of whatever x value, but in this case, we're calling the x-axis t, so t equals 3.25. All right, let's move on to a completely different problem. And actually, the next series of problems here are going to be more typical quadratic problems. One type of quadratic problem is often this kind of thing, where a quadratic models the motion of something on planet Earth, a path of a projectile. And another set of very common quadratic problems have to do with areas, because when we multiply 2 dimensions, we get a quadratic, basically, equation. So here we go. We have a rectangular enclosure with a 42-meter fence around it. So imagine you have a rectangular fence around some kind of yard, and the fence in total is 42 meters long. So all these lengths here together, that's 42 meters of fence. And it says the area is 90 meters squared. So let's break this down into several parts. First of all, we're going to use x for width and y for length. So x and y. Now I want you to write an equation for the area, okay? Just a simple equation for this area here. We have x, we have y. What's the area equation? Well, the area is x times y. To find the area, we do length times width, x times y. Great. But we are given the area of 90 square meters, so why don't we replace a with that area figure right here. So 90 equals x times y. Excellent. Let's do the same thing for perimeter. Write an equation for perimeter using x and y, and then use the 42 meters you're given, because the 42 meters is the full length of the perimeter. So first equation, and then put that 42 into it. All right, here's our equation then. Perimeter is made up of 2 of these x lengths plus 2 of these y lengths. So I wrote that here, and it is equal to 42 meters because the full perimeter is 42. Okay, there's that equation. So now we have one equation and another equation, and they both have the same 2 variables. This is called a system of equations. We can somehow combine those to help us solve for x and y. So that's what it says next. Combine the 2 equations above to create a new equation for area in terms of x only. If we're going to change this area equation to be in terms of x only, that means this y has to disappear. And the only way to make the y disappear is to take this one here, solve for y, and then substitute it in there. Okay, so take this equation first and rearrange it so that it becomes y equals something. Okay, so there's that equation. First I divided everything by 2, and then I subtracted x on this side. And that gives me y equals 21 minus x. So now that can be substituted in here. Oh, by the way, now that I solved how long that is, I can put that as that length, right? So now I know the rectangle has dimensions x times 21 minus x. So here's my area equation. I'm going to replace the y with what I just found y is using the other equation. Replace it here. And now I can multiply this out actually to create a quadratic. Well, it is a quadratic, but we're going to multiply it out, so do that. Yeah, that's our next stage. We're going to solve to find the dimensions of this rectangular enclosure. We're going to solve this equation for x, because once we solve for x here, we will know how long this is, and then we can get how long this is as well. So let's solve this. Multiply this out, get 0 on one side, because that's how we solve quadratics, right? Okay, multiply this out, you get 21x minus x squared. Move the 90 over, we get this. Actually, I took these ones, I moved them to the other side so that I can have a positive x squared. So I added x squared over here, here it is, and I subtracted subtracted 21x over here. So I have x squared minus 21x plus 90 equals 0. Now this can be solved. If we can just factor this, we can use the null factor law because we have 0 here, right? So factor this. Okay, that factored is x minus 15 times x minus 6. Great, now solve each of these using null factor law. Okay, that one is set equal to 0, and this one is also set equal to 0. The answer here is 15. The answer here is 6. We have 2 possible answers for x. So this length here can be either 6 or 15. So what does that tell you about the 2 possibilities for y? Well, that tells us we have dimensions of x by 21 minus x. Dimensions mean the length and width of a shape, right? And that means it can either be 6 by 15, because if x is 6, and you put a 6 in here, then this must be 15. So 6 by 15 is one option. The other option is actually 15 by 6 again, right? Because x can either be 15 or 6. So notice x can be 6, that becomes 15. Or if this is 15, then that becomes 6. It's just basically saying the same thing. All right, excellent. We found out the dimensions of the rectangle. Now you are ready to try this problem. So see if you can, based on what you read here, can you label the 2 dimensions of this rectangle here? Okay, well, we can call one thing x. Let's say this length is x, and it says the width is 3 centimeters less than its length. Okay, that means this must be x minus 3, because it's 3 centimeters less than this length. So we have our 2 dimensions, and we're told what the area is. So go ahead and write an area equation, which will be this side times this side, and we know it's equal to 18. So write that equation and see if you can solve it. Here's our area equation, and we know area is 18, so that's what we have. Multiply those to get this. Move the 18 over so that we have 0 equal to the quadratic, and then let's factor. Factoring that, solving it, here's the factored form. Here is us solving this one for 0, here's solving this one for 0. We get 2 answers, 6 and negative 3. The quadratic produces 2 answers, but obviously a rectangle cannot have a negative length, so I've outlined this one as our only possible answer in this situation, x equals 6. So now that we know x is 6, we can say what the 2 dimensions of the rectangle are. This is 6, and this is 6 minus 3, which means our dimensions are length 6, width 3, and notice if you multiply those 2, you get the area that we were given. Great, pretty basic problem, but again, very common, the idea of areas represented by quadratics. So let's keep getting a hang of these. Here's your next one here. Okay, we have a length of rectangle is 1 centimeter less than 2 times its width. So a little bit more complicated than the last one, but the same idea. We're trying to label these. Okay, 1 centimeter less than 2 times its width. So let's say the width is x, and then the length is 1 centimeter less than 2 times the width. So see, 2 times the width here, and 1 centimeter less than that. Ponder that for a moment if that didn't come to you very quickly. Read these words again and make sure you understand this setup. All right, we know the area is 45. So let's solve it. Write an area equation. and let's solve it. Okay, area is these two dimensions multiplied, that, and then we know area is 45. Okay, so our area is 45. Now I've multiplied these two to get 2x squared minus x. We want 0, move the 45 over. We have 2x squared minus x minus 45. Now can you factor this? Okay, that one takes a little more work with factoring because we have an a value that is not 1, right? So 2 times negative 45 is negative 90. And then here we have a negative 1. So we need two numbers that multiply negative 90 but add up to negative 1. Those two numbers are negative 10 and 9. So notice I have them here. I'm going to do factoring by grouping because again this a value is not 1. Grouping, factoring. And now I have something times something by null factor law. This factor can be 0 or this factor can be 0. And we're solving to get two answers. This gives us a negative answer. Again, we cannot have a negative dimension or length here, so this is our only possible answer. So if x is 5, that means this is 5, and then this has a length of 9. So our dimensions of this rectangle are 5 by 9 centimeters. Great job. Let's try a few more. Here's the next one. Similar setup. You're reading these words, trying to label the dimensions of this rectangle using the area and solving. Let's see if you can do this one from beginning to end. All right, here are our dimensions. We are told that the length is 2 meters less than twice its width. Okay, 2 meters less than twice the width. So here's twice the width, 2 times x, and 2 meters less than that. There's our setup. There's our area formula. Area is 420. We have this. Multiply these to get this. Move the 420 over. We have this. In this case, it may first look like we might need to do factoring by grouping, but in this case, we can actually factor out a 2 from all of these. So it's going to be a little easier. Divide everything by 2 here, and you get this. And then it's a little bit of an easier factoring problem. So, negative 210 here, negative 1, two numbers that multiply to that. Here they are. Factor, solve, negative 14, discount that answer. It's called an extraneous solution, and then this is our possible answer here. If x is 15, then this here must be 28. So our dimensions are 15 by 28, and it should say meters here. Great, let's keep going. You're doing great. Here's now areas not limited to rectangles. Of course, we can talk about triangles and other shapes as well. So please take a look at what you see here. You're given the area, and let's see if you can set up the equation and solve this one. Okay, so I called the height x. I could have kept it as h, but anyway, here's x, and I'm calling the base x plus 17. Why? Because it says the base of the triangle exceeds its height by 17, so it's 17 bigger than the height. Okay, x and this. Now, obviously, the area of a triangle is a formula you should know, and it is base times height divided by 2, or base times height times a half. So in this case, our base is x plus 17, our height is x, and we put a half there because it's a triangle, not a rectangle. All right, we know the area is 55, so I've replaced that. Now it's the same as the problems before, we just have to solve this. One thing I suggest often is when you have a fraction, why don't you get rid of it? To get rid of this half, you can multiply this whole side by 2 and it'll cancel that. But then we also have to multiply this by 2. So everything has been multiplied by 2 like this. Now multiply these out to get x squared plus 17x. Move the 110 over because we need 0. So there's 0 equals that. Factor that. Okie dokie. This factored, you can see here I've set up the factoring x factor technique to get 22 and negative 5. So here's factored form. Set both factors equal to 0. Solve. Discount the negative 1. Here's our possible answer for x. So if this is 5, this is 5 plus 17, so that is 22. We have found the height and base of this triangle. Great. How about trying this one? They're getting a little tougher. Not too bad, but a little tougher. We have two shapes here, a square and a rectangle, and there's some words given to you about the relationship between dimensions here. So see if you can label them and solve this one. A little more challenging. Okay, we are told that the length of the rectangle is 5 more than twice the length of the square. Okay, sorry, yeah. So here's a square. A square has equal length sides. So I call them x by x. And then the length of the rectangle is 5 more than twice the length of the square. So twice this, which is 2x, and 5 more than that. And then the width of the rectangle is 6 centimeters less than the side of the square. So it's the side of the square minus 6. So there's this connection between the two shapes. I hope you're able to come up with that. And finally, it says a square and rectangle have the same area. So even though these are different, we have a rectangle, square, they end up having the same area. So the area of this equals the area of this. Okay, so the area of a rectangle equals area of a square. And here's all the work for that, right? The area of the rectangle is found by multiplying those two dimensions. And the area of the square is found by multiplying these two dimensions, x by x. We have our equation. This part here multiplied out gives us this. Over here, x times x, x squared. Again, we need everything on one side and 0 on the other. So I'm going to take this x squared and subtract it over here to get just x squared. And now I have a quadratic equal to 0. Factor that, here it is. And set each factor equal to 0 and solve. Here's our possible answer for x. So this is 10, this is 10, this must have an area of 100. Let's check if it works, because 100 should be the area of this as well then, because they have equal areas, right? So now put 10 in here, 10 minus 6 is 4, put 10 in here, 2 times 10, 20, 25, so 25 times 4, oh good, 100 also. Everything works out. That x value produces a rectangle and square with equal areas. Okay, here's our next problem. We're given a triangle. It is a right triangle, and it says find the lengths of the sides. Well, you should know a very important rule or theorem about right triangles and its sides. What is that theorem? It is the Pythagorean theorem, and we know it is a squared plus b squared equals c squared. That's the one leg squared plus the other leg squared equals the hypotenuse right here squared. So replace this equation with these things squared, and let's see what we get. Okay, so x squared plus 3x plus 3 squared. We have the parentheses around it because it's that whole thing squared, and then equals the hypotenuse, again, parentheses squared. So now expand all these brackets here. You can expand this. What does this become? What does this become? Okay, over here, x squared. This is really 3x plus 3 times 3x plus 3. And this is really 4x minus 3 times 4x minus 3. Multiply all that. We get all this. Okay. So over here we had x squared, and then this all expanded is 9x squared plus 18x plus 9. And over here is 16x squared minus 24x plus 9. There's a lot of things here. But underneath it, we do the same thing always. Get everything on one side and get 0 on the other side, all right? So I'm going to subtract, let's see. Oh, I have 10x squared here if I combine those. And then I can subtract 10x squared from both sides, and this becomes 6x squared. And then I have 18x, so I can subtract 18x from here, and then I get negative 42x. And I have 9 and 9, so those two subtract on both sides, and they're gone. I'm left with this pretty simple quadratic. We don't even have to worry about x factor because there's only 2 terms here. So we can just do Gcf factoring for sure. I factor out 6x here, and I get this. Now I can set each factor equal to 0, 6x equals 0, and x minus 7 equals 0. Solve, solve. We have a possible answer of 7. So if this is 7, then this is 3 times 7 plus 3 is 24. And then this is 4 times 7 minus 3, which is 25. So our dimensions of this triangle are 7 by 24 by 25. All right. I think we are on the last one. See if you can set this up. It explains something here about a pole leaning against a vertical wall. So this is the wall, this is the ground, this is the pole leaning on the wall. Tells you what you have here. See if you can solve it. Okay, so it tells you we're looking for the distance that the pole is from the wall right here. We're told this is a height of 15, and we're told that this length of the pole is 1 meter more than twice the distance from the wall. So here's the distance from the wall. Twice that distance and 1 meter more. So again, we have a right triangle. We can use Pythagorean Theorem. Try it out. So here's Pythagorean Theorem. And I've put all the parts in here. A squared plus b squared equals the hypotenuse squared here. I'm multiplying things out. 15 squared is 225. Here's x squared. This thing multiplied out becomes 4x squared plus 4x plus 1. Get everything on one side. and we have 3x squared plus 4x minus 24. Now, does this factor? Try as you might, you will not be able to factor this. Not every quadratic factors. I know we're getting used to the idea, but not every quadratic factors. When a quadratic factors, we can get nice, easy whole number answers often, but sometimes it doesn't factor. And that implies that there's more answers that are going to be more difficult decimals, basically. So basically, we have options. If you cannot factor, we can use something called the quadratic formula, which we haven't learned yet, but we'll get there soon. You'll learn that one very soon. Otherwise, people know this kind of as Viet's theorem. Also, other options are you can use what is called the Poly Simulation number 2 app on your graphing calculator, but you might not have your calculator nearby right now, so don't worry about that either. I'll show you that later. For now, I'm just going to go online, and there's all these online quadratic solvers that can help us. So I've got one ready for myself here. I just searched online quadratic formulas calculator, and I found this. See, it has a quadratic here in standard form equal to 0, and it allows you to enter the coefficients. And once you enter those, it'll give you the answer. So let's see, back on ours, we have 3, 4, and negative 224 are our 3 coefficients. So that was 3, I think, 3, 24, oh, I forgot already. 324, no, 3, 4, and negative 224. 3, 4, and negative 224. Calculate. It's going to give me my 2 answers. It's working on it. Wow, okay, it's trying really hard here. Let's see what it gives me. It's trying. Why is it working so hard? I don't know. Oh, there we go. One answer is x equals 8. Okay, that was a whole number. But the other one is negative 9.33333. Okay, so it gave me my 2 answers there. Let's look back here. Is that the same 2 I have here? I believe so. There's 8 and there's negative 56 over 6, which is that same 9.33333. There's our 2 answers. So ignore the negative answer. Let's use the positive answer it makes here. So our dimensions of that triangle would be 8 by 15 by 17. Okay, excellent. I am at the last problem with you now. This one is a challenge. I will let you challenge yourself by trying it, and then I'll help you out through the steps. This is a good one. Let's try it out. So read this. See if you can draw the frame that is described to you. And let's see if you can solve it as well. Okay, now that you've tried, let me help you with the problem. The situation is kind of funny. Yeah, if the photo that your girlfriend, boyfriend gave you fits in the frame, you will stay together. If the photo doesn't fit, you will break up. Well, check this out. Here's the photo they gave you. Whoa, okay. Oh, yikes. Okay, so, not to judge, but maybe you hope the photo does not fit in there because maybe you want to break up. I'm not sure. Let's try the math. So here's this frame, and it was the photo, and it said the photo has this black border around it. So imagine this is where the image is, and here's that black border. Okay, it told you that the photo itself is 15 by 22. Let me double check that. 15. Yep, with a black border. Okay, 15 by 22. It also told you the black border is uniform width. That means it has the same width all around. So if this width here is x, then this is also x, here to here, and this is also x, and this is also x. Like every part where you mark how wide it is, the black part, it's x. Okay, it's some unknown width. We don't know what it is, but we know it's uniform. Okay, that will allow you to write. Now, we have the dimensions of the inside, 15 by 22, but what are the dimensions of the whole photo then, if you know all these x's here? Well, this is 15 plus 2x, because it's 15 plus this width plus this width, and each of those is x, so 15 plus 2x. And then the entire height is 22 plus 2x, because it's this 22 plus this x bit here, like this here, and this part is also x. So there we go. Now, what is the area of the entire photo? Well, we were given that the entire photo, I think, is 120. Is that right? No, I think, let me go back. I'm confusing myself. I can't remember the details. The border, the black border has an area of 120. Okay, so let me jump ahead to that. The black border has an area of 120. So 120 represents the black border. But to find the black border, we can say the black border area is, if you take the whole photos area minus. Okay, let's try this again. So we were told the black border has an area of 120. And to find the area of the black border, we can take the full picture's area minus the white portion, right? If we take that full area minus the white portion, we're left with just the black border area, which is 120. So I'm going to do 120 equals the full picture, which is 22 plus 2x times 15 plus 2x, right? It's these full dimensions, minus 15 times 22, which is this white part. Again, the border we get from multiplying both full dimensions, so the full rectangle minus the white inside here. All right, let's solve this equation. This multiplies to this. We have the minus 330 here from this part at the end. All right, let's get everything combined and 0 on one side, so these two can combine, and on and on. Here's 4x squared, here's 74x because of these two. There's a 120. These two 330s cancel. Now we can actually move the 120 over to this side and we have 0. So now if we can factor this, we can solve for x and we'll know how big our borders are here. I mean this part here, and we can figure out how big the picture is and so on. So factoring that. Okay, here's all the work. I first factor a GCF of 2 because it's going to make these numbers smaller here and it will make it easier to factor. So looking at those numbers, 2 times negative 60 is a negative 120 here. 37 is here. I needed two numbers to multiply to get this that add up to this, and they are 40 and negative 3. So here's the 40, negative 3, factoring by grouping. All that work, here we are, factored form. If you solve each of these, you get x equals negative 20 from this one, and from this one you get x equals 1.5. When you set this equal to 0 and solve, you get 1.5. This answer is no good, negative answer, but 1.5 is our answer. So it tells us these values are all 1.5 here. And that means this entire length, 15 plus 2 times 1.5 is 15 plus 3 is 18. This is 18, and this is 25. So our photo is 25 by 18. And the original frame was smaller than that. So the photo's too big to fit in the frame. Good news, you're breaking it up. All right, thank you for hanging in there for this challenge problem. Actually, this whole video might have been a big challenge for you. These problems are not easy, and solving quadratics is a very important skill in mathematics. I hope you've learned a lot, you've tried a lot, and you've had some success. There is some more practice for you. If you enjoy a good challenge, I have some even more challenging problems for you. You can find them in the same lesson. In the Collaborate section, there is a link to a PowerPoint with more challenge problems. They're going to get challenging, especially by the end. You will be, wow, you'll say, wow, these are tough. And good news, as you do a problem, the answer is given always on the next slide. So you can always check your work and see how you're doing. Please practice those now. See you later. You can do it.